So here's what I'd like to do. I'm gonna draw an angle for you, and we're gonna pretend we're gonna call that angle. Let's call it 150 degrees. Okay, so let's call this theta at 150 degrees. Easy enough? Yeah, pretty good. Okay. So that means, so what would this leftover angle be down here? If that angle theta is 150 degrees, what would that leftover angle be? This would be 30 degrees, right? Okay, so here's what we're gonna do. In our calculators, let's figure out what's the sine of 150 degrees. Okay. What is the sine of 150 degrees? Well, I'm in degree mode, so let's just go ahead and check it out. You guys this one should look familiar to you. What do you get? You should get 0.5, right? And what about that left angle? What about that left angle? That leftover angle down below? What's that one? 30 degrees, right? So the sine of 30 degrees. What do you notice? Same thing, right?
Whoa.
Crazy, right? Because they're coterminal with each other, except one is in quadrant 2, and the other one would be in quadrant 1, right?
Would we be using the word supplementary today?
No, but yeah, that's pretty clear, right? The supplemental angles, right? What about this one? Now, is this true for the cosine, I wonder? So we saw that the sine and the cosine of these two angles that represented by the picture, these were the same of 1/2 and 1/2. What about the cosine, though? What about cosine of 150? What do you get when you plug in the cosine of 150? All right, let's plug in the cosine.
Negative 0.86.
Okay, I get negative 0.866, blah, blah, blah. Okay, what about the cosine, then, of 30? What do we get? Notice we get the positive of that angle, right? But what quadrant are we in? We're in quadrant 2, right? That angle for 30 degrees, or that angle for 150, is the same as the angle of 30, except it's over there in quadrant 2. So doesn't it make sense that it would be negative? You guys follow along so far? Okay, so what I'm getting at is, and this works the same for all of these trig functions, okay? So what I'm really getting at here, and we can use, I'm into these like thick markers now, it's kind of fun. So,
Are we not going to keep on?
so here's what I'm getting at, right? So let's say that we have any old point over here, x and y. And I have some theta over here drawn like this, okay? Well, to get to any angle around my circle, we were stuck in this unit circle, and we only knew what to do when the radius was equal to 1. But in this case, we're going to extend that radius, let that radius be whatever we want it to be. And we're going to define some new terms here. So if I were to draw sort of a triangle here, right, we could define the sine, the cosine, the tangent, and everything just like we did before, except now, instead of our radius being 1, we're going to let our radius actually just be r. So this is my x direction, this is my y direction. And I'm just drawing a general picture, kind of ignoring signs for right now just to get the idea down. All right? So with this general picture here, we can now define sine theta to be the opposite over the hypotenuse, right? Well, now, theta is that outside angle, but there is this special relationship between the outside angle, that big one, and that little one inside there. They turned out that they are the same in terms of their sine, cosine, and tangent. They're just in different quadrants. So if we take into consideration what quadrant they're in, we're going to be okay when we deal with these answers. So the sine of theta, it used to be that sine theta was only y values, right? It would be y divided by the radius, which was 1 every single time. But now, since we have a radius of whatever we want, we can redefine the sine as being y divided by r, where r is any length that we have. So the sine of theta is still opposite over hypotenuse. So opposite y over hypotenuse r. What's the cosine of theta then defined to be for any angle? No. Cosine deals with x over r. Nice job, Rachel. And then tangent of theta is going to be defined to be as y over x. Yeah, very good. So if we know the top 3, do we know the bottom 3?
Sure.
Yeah. Cotangent of theta is x over y. Secant of theta is r over x. And cosecant of theta is r over y. Now, of course, x and y cannot be 0, otherwise we get some undefined terms. And since I have a right triangle, is there a relationship between the sides of the triangle and the hypotenuse? There's a Pythagorean theorem, exactly. We know r squared is always going to be x squared plus y squared, because I'm dealing with a right triangle. But I don't care for r to be squared. I'd rather have it to be r. So that'd just be the square root of x squared plus y squared. So this right here lays the foundation for everything that we're going to be doing in this whole entire section. So given that the point -3, 4 is somewhere in the coordinate plane, we're going to use that to find all 6 trig functions, okay? So first what we're going to do is we're going to draw a picture of the situation. So I'll draw a picture. Whoa, that was terrible. Let's go this way. Okay, so -3, 4, that's -1, -2, -3, 1, 2, 3, and 4. So there is some point in the plane over here. There's -3, 4. And I have a radius here that's drawn to it. So I'm going to draw my triangle in quadrant number 2. Okay, and this is the angle that corresponds to that point in the coordinate plane. But as we saw before, there is a leftover angle, which I'll just call theta prime for right now, which is representative of all the same ratios as it was for theta. So all we need to get is r. So r is going to be the square root of x squared plus y squared. So r has to be, like, what distance does that have to be?
5.
Yeah, if this is a -3, if this is a 4, then this has to be a 3, 4, 5 triangle. But just to verify, notice we'd get -3 squared plus a 4 squared. So yep, there it is, square root of 25. So r would definitely be 5. Good, so now that we've drawn a picture and we've gotten our radius, we have all the pieces of the puzzle that we need. So the sine of theta, remember, sine of theta is defined to be y over r. Which one is the y value in this case? Yeah, the opposite of the hypotenuse, right? The opposite is 4, hypotenuse is 5, so the sine of theta has to be 4/5. What about the cosine of theta?
-3/5.
Yeah, the cosine of theta has to be, yeah, the adjacent over the hypotenuse, so -3/5. So even though I'm talking about this angle in here, it's the same ratio as that angle outside, except in quadrant number 2. So it makes it negative, right? I realize those angles are different, but the ratios that they produce for cosine are going to be the same. Okay, and then the other one we need is what? Tangent, right? Tangent of theta is going to be the definition of y over x, so that's going to be -4 thirds? Yeah, -4 thirds. Okay, good. So if I have those, then I know cotangent of theta, what would it be? -3/4. What would the secant of theta be? -5 thirds. And then what would the cosecant of theta be? 5/4. Awesome. So that is what we're looking for. Okay, so let's talk about some notation. You see here I've got the quadrants all laid out. Where's quadrant 1?
There, right?
There. I love when you guys just point. Yeah. Where's quadrant 2?
Across from that.
Across from that, right? Quadrant 2. Where's quadrant 3?
Below bottom left.
Good. And then finally quadrant 4 is over here, right? Okay, good. Now, so inside quadrant 1, if I was going to draw an angle in quadrant 1, which two angles is it guaranteed to be between if I'm in quadrant 1? Look on the picture. Between where?
0 and
Between 0 and pi over 2. So the notation would be something like this. 0 is less than theta is less than pi over 2. So when you see this notation, you know you're in quadrant 1. Is that fair enough? What would it be in quadrant 2? Pi over 2,
is greater than
less than theta,
which is
less than pi. Very good. So if you see this, that means you're in quadrant 2.
So, like, if they give you that notation,
Yep.
they're like, find it between this.
Yes, you have to know what quadrant you're in, exactly. What about third quadrant, what would it be? Pi is less than, theta is less than 3 pi over 2. Good. Okay, we're doing good. How about fourth quadrant, you guys?
Yeah, pi over 2 is less than theta is less than 0.
3 pi over 2 is less than theta is less than 2 pi. Because all the way back around is 2 pi. Right?
Yeah.
All right, so there's some notation for it. Okay, here's the setup. The setup says this. If the tangent of theta is -5/4 and the cosine of theta is greater than 0, find the sine and the secant of theta.
This is where it's hard.
No, not at all. Okay, so let's go with black. Okay, so check this out. all students take calculus. Abby says no way. What does this mean? What does this represent?
In that quarter, sine is positive, in that quarter, tan is positive, and in that quarter.
Yes, so what this tells you, it says in quadrant 1, all trig functions are positive. In quadrant 2, only the sine is positive. In quadrant 3, only the tangent is positive. And in quadrant 4, only cosine is positive.
So right off the bat, it can't be in here.
So check it out. If we know tangent is negative, where can it not be? It can't be quadrant
Quarter 3.
1, and it can't be quadrant 2. Okay? So that means it can only, 3. It means it can only be in quadrant 2 or 4. How do we determine which one it is?
Its cosine is greater.
Yeah, cosine is greater than 0, meaning it's positive. So where is it?
4.
So we are in quadrant number 4. Why is that important? Can I go for that again?
Yeah, I'm just confused about the AS.
If we know we're dealing with a quadrant 4, let's draw a right triangle in quadrant 4. Okay? There's my theta. I'm in quadrant 4. And I know something about this particular right triangle. What do I know about this right triangle? I know the tangent is negative 5 over 4. So that represents, remember, y over x up at the very top of our first box, right?
Yeah.
So that means that I go over how many units? 4 units over, and how many units down? Negative 5. Good. So that means I have a radius here. What would that radius or the hypotenuse be for that right triangle? Well, it would be the square root of 4 squared plus a negative 5 squared, which is the square root of 41 when you figure this all out. Because 16, 25, add them together, you get 41. We're going to leave it like that. Okay, so now it's asking me for the secant and the sine. Well, the sine of theta was determined to be y divided by r. So that means the y value I have as what? Negative 5, good.
Why is the sign
So
on
it's negative 5.
And then opposite over hypotenuse. Sine of my angle here is opposite over hypotenuse, right? And then the r value is root 41. Of course, we can't leave it like that. So we go negative 5 root 41 over 41. There is the sine of theta. Everybody good?
So did you just
Okay, did you guys come up with secant theta is root 41 over 4? Yes, awesome, very good. Okay. Yes, quite a lot. So here's the idea behind a reference angle. Definition says the acute, so like you just told me, so that means some angle that's less than 90 degrees. Has to be positive. That's between the terminal side and the x-axis. So here's the deal. I'm going to draw for you an angle in quadrant 1, an angle in quadrant 2, an angle in quadrant 3, and an angle in quadrant 4. Now notice that those are all my angles, okay? Angles theta, angle theta, angle theta, and then angle theta, right? So the question is, where is the reference angle for each of these? So I'll draw the reference angle for you in red. The reference angle is the same as theta in quadrant 1 because it's positive and it's less than 90 degrees. So that one right there is my reference angle, which I'll just label as RA. That's not a big deal. Okay, let's go over to quadrant 2. This is the terminal side, right? This longer one. And it says it's the acute angle, it's positive, and it's between the terminal side and the x-axis. So that means that the reference angle is right here. This is my reference angle. It's the small angle, less than 90, between the terminal side and the x-axis. Now that reference angle, if you're paying attention, is the same as in the very beginning. Remember I said sine 150 and sine 30? That's because they're reference angles with each other. But it's in quadrant 2, so we just attribute the sine to it. Okay, in quadrant 3, the reference angle would be here, right? This is the small acute side. That's positive between the terminal side and the x-axis. And then finally in quadrant number 4, the reference angle would be here. This is my reference angle. So the reason I'm giving these to you is because a lot of times students draw them in the wrong spot. They draw them between the terminal side and the y-axis. Make sure you always choose the x-axis for it. Let's say that we're trying to figure out the sine of 300 degrees, the exact value, okay? So what we're going to do is I'm going to draw a picture. Now, where is 300 degrees? It's in quadrant 4, right? So it looks something like this. There's my angle theta, right? So what's the reference angle of a 300 degree angle? Yeah, that means that my reference angle is 60 degrees. So the sine of 300 degrees is the same as the sine of 60 degrees, but in quadrant number 4, right? Because my angle actually is in quadrant 4. So do we all know and love the sine of 60 degrees? How much is it? It's sine of 60 degrees is pi over 3. What's the sine of pi over 3?
1/2.
Sine of pi over 3.
1/2.
No, sine of pi over 3.
3/2.
Root 3 over 2. But I'm in quadrant number 4. Are signs positive or negative in quadrant 4?
Negative.
They're negative. So therefore, this is equal to negative root 3 over 2.
Why is it?
Oh.
Okay, cosine of negative 135. Cosine of negative 135. So let's go ahead and draw this angle. Where is negative 135 degrees?
Quadrant 2.
Quadrant 3, right? Because that right there is theta equals negative 135 degrees. So what's my reference angle left over?
45.
Yes, good. So check this out. The cosine of negative 135 is equal to the cosine of 45 degrees, but in quadrant number 3. And in quadrant 3, cosines are, because look where that angle ends up. The terminal side ends up in quadrant 3, right? That terminal side is in quadrant 3. So we know that this is, the cosine of 45 degrees is root 2 over 2, but because I'm in quadrant 3, it's negative. Negative root 2 over 2. So therefore, where is negative 210 degrees?
Quadrant 2.
Quadrant 2. Negative 210 degrees is this angle here. So what is the reference angle?
45.
Nope. Nope.
30.
30 degree reference angle. Right? Because if I just go halfway, I've gone negative 180. Then I have to go another 30 to get to negative 210, right? So the reference angle is 30 degrees. So therefore, the tangent of negative 210 is the same thing as the tangent of 30 degrees, but in quadrant number 2. What's the tangent of 30 degrees?
Tangent of 30 degrees. I don't know.
It's root 3 over 3, but in quadrant 2, are tangents positive or negative?
Negative.
They are negative. Very good. So the tangent of negative 210 is negative root 3 over 3.